Hello everyone. So today we are going to understand the concept of binary search. So let's say you have a book and book have total 500 of pages. Okay. And let's say you have to find the page number 267 for example. So how you are going to search? You will randomly open the book and let's say the page number which get open is 310. Okay, now you are sure that you need to search for 267 in the left hand side. Okay, so this from page number 311 to 500, this is of no use now, right? We can ignore this page. Again, let's say that I start searching from 0 to 310 and I landed at 167 for example. So again, I am sure that my this part of the book page is of no use. So my answer lies between 167 to 310. So let's say that after again searching, I landed at 280. Okay. So I am again sure that this is not my answer space. So I will again look my output in this area only. Okay, and let's say that I ended up at 267. So this is the concept of binary search. So binary search is the most powerful and efficient searching algorithm. But the problem with the binary search is that it only works when our input data is sorted. So let's say I have to search, my target is 15 and I have to search 15 in this array. So how we are going to use binary search for this? So what we will do, we will initialize two pointers. First one will be low and the other one will be high. So low will point to the start of the array and high will point to the end of the array. And every step we are going to find the mid element. Okay, so how we are going to find a mid element? So mid element is basically high plus, so mid element will be high plus low by 2. So in every iteration I am going to calculate the mid element. So here by calculating mid element, so mid will be 3. Okay, now I will compare whether 15 is greater than array of mid or not. So I will at every iteration I am going to compare whether my array of mid is smaller than is equal to target. If it is equal to target means we find our index. Okay, at where my target is present. This is the case 1. Other case is if array of mid is greater than target. So let's say that our target is 15 here, and let's assume that array of mid we are somehow standing at 20 here, right? So this is array of mid. Okay, so here array of mid is greater than target. It means that my answer lie between from low to mid minus 1. Okay, so what I will do here, so I am going to update my high to mid minus 1. In case if my array of mid is smaller than target, so what I am going to do in this scenario, where when my low is at 0 and high is at 6, my mid is equal to 3. So here my target is greater than low. My target is greater than array of mid here because my mid is here right now. So I am pretty sure that my answer lie between from mid to high, right? So what I will do, I will update my low pointer from 0 to mid plus 1. Okay, and how many times we are going to do this? We are going to do this until unless while my low pointer is less than equal to high, and every time I am going to update my mid. How we are going to update my mid? So we are going to update my mid by high plus low by 2. Okay, and we will check these three conditions. So the condition first is if array of mid equal to target. So my target is present at this particular index, so I will return the mid. Other case, if my array of mid is greater than target, it means that we need to decrement our high pointer. Okay, so in this scenario, what we will do, we will going to update my high pointer to mid minus 1, else we are going to update my low pointer to mid plus 1. In case we are not going to find my target element within the particular array, so we are going to return minus 1. Okay, so let's do the dry run here. Okay, of this example only. So in first iteration, what happened, my mid is at 3, so I fall under this condition. Okay, that my target is greater than uh, array of mid. Okay, so what I will do, I will update my low pointer. So my low pointer will be now mid plus 1 means 4, and my high pointer is still at 6. Okay, now again I will calculate mid. So my mid will be 5 now. Now again I will compare where array of mid, I will compare array of mid with the target. Okay, so array of 5 is 20. Okay, so here again array of mid is greater than target, so what I will do, I will update my high to mid minus 1. Okay, so again after this iteration, since array of mid is greater than target, I will update high to mid minus 1, so high will become 4. Okay, now after this iteration, my low pointer is at 4, my high pointer is at 4, and my mid equal to 4. And now I find array of mid equal to target, so I am going to return my mid index. Okay, so this is how binary search work. Okay, so let's understand the time complexity of binary search. So in binary search, what we are doing, so in each step what we are doing, we are dividing the search space into half. Okay, so we are dividing our search space in half. So let's say that after one step, okay, after one step, my search space is n by 2. Okay, because in this case only, in what we did after first iteration, my search space will become from mid to high, right? So I ignored the half of the element from the array. Okay, similarly after one step, my search space become n by 2. After 2 step, it will become n by 4. Similarly after 3 step, it will become n by 8, and after k step, my search space will be n by 2 to the power k. Now when we are going to stop, we will stop when the search space is reduced to one element. So when n by 2 to the power k equal to 1, then we are going to stop. Now we will solve for k here. So while solving for k, we find that n is equal to k equal to log base 2 of n. Okay, so my time complexity is log of n. Okay, so let's see the coding part, and then we will continue. Hello, so let's see the code part of binary search. So first we will define a function binary search, and we will take the array and target as input. We will define the 2 pointer, one is low, one is high. So high will be at the last element of the array, and we will iterate over low and high. So we are going to iterate over low and high till low is less than equal to high, and every time what we are going to do, we are going to calculate the mid element. So first we will calculate the mid index. So how we are going to calculate it? High plus low by 2. and then we will check if array of mid is equal to target. If yes, then we will return the index. Now case 2 is that if array of mid is greater than target. So in this case, what we were doing, we were updating my height to mid minus 1, else we were updating low to mid plus 1, right? And if we are not able to find the target, then we are returning minus 1. So let's define an array. So let's say our array is 1, 2, 3, 4, 5, 6, 7, 8, and let's say that target is 7. Let's call this function and let's see. So it is saying that 7 is present at index number 6. Okay, let's pass 10. It is returning minus 1 because minus 1 is not present. Let's pass 1. So 1 is at present at index 0. So I hope you enjoyed the video. If you have any feedback, you can comment in the video section. Thank you. Have a nice day.